We're going to solve more logarithmic and exponential equations today, starting with logarithmic equations. Here we have a suggestion. When there is only one logarithm in an equation, isolate it, and then we can change it to exponential form. So we only have one log, and it is isolated, so let's change this to exponential form. Base is 2, exponent is 5, so 2 to the 5th equals x plus 2. 32 equals x plus 2, and x equals 30. And we have solved this equation. We want to check that 30 plus 2, 32. The exponent we raise 2 to get 32 is 5, so it checks. And here's a reminder that we must always check. Because the domain of a log function is only positives, it's necessary to check our solutions to make sure they result in positive numbers in the original equation. So we're only looking for logs of positive numbers in the original equation. Solving this equation, we've got one log, so let's isolate this. First, we'll subtract 4 from each side, and we'll have 3 logs of 2x equals 12. Oh, this is 3 times. I can divide by 3, and I'll have the log of 2x equals 4. So this is a common log, base 10. So 2x equals 10 to the 4th. 2x equals 10,000. And x equals 5,000. Now checking that rule to make sure I have the log of a positive, 2 times 10,000, or 5,000 would be 10,000, so I would be taking the log of a positive number. And I'm okay. Now in this case, we happen to have 2 logs in this function. And it says, when solving a logarithmic equation, consider forming one log on one side and then converting it to the equivalent exponential form. Well, to get these all on one side, I'm going to subtract the log of x minus 4 from both sides. That will give me the log of x plus 8 minus the log of x minus 4 equals 1. I can combine this into one log. It's a subtract, which means the arguments are divided. The log of x plus 8 over x minus 4 equals 1. Now I've got one log on one side equaling number. I can change it to exponential form. This is a common log, so the base is 10. So x plus 8 over x minus 4 equals 10 to the 1st, or 10. Either cross multiplying or multiplying by x minus 4, I get x plus 8 equals 10x minus 40. And that means 9x will equal 48, and x will equal 48 ninths, which can be reduced, so x equals 16 thirds. Now, I still must remember to check and make sure I have positives. So 16 thirds is 5 1/3. So 5 1/3 plus 8 would be positive. 5 1/3 minus 4 will still be positive 1 1/3. So that this answer does check. Now these are log base 2. And I'm going to combine these to 1. So log base 2 of x times x plus 2. Since these were adding, that means they were multiplied, equals log base 2 of 6x plus 1. The only way that can happen if these two logs are equal is if the two arguments are equal. So x times x plus 2 must equal 6x plus 1, or x squared plus 2x minus 6x minus 1 equals 0. x squared minus 4x minus 1 equals 0. This does not factor. So I'll have to use the quadratic formula. X will equal negative b, so 4 plus or minus the square root of b squared minus 16 minus 4ac. So minus 4 times 1 times negative 1 will be plus 4 all over 2a. So x equals 4 plus or minus the square root of 20 over 2. So x equals 4 plus or minus 2 square roots of 5, since 20 is 4 times 5. And I take the square root of 4 out of 2. It's 2. Now everything is, all terms are divisible by 2. So x equals 2 plus or minus the square root of 5. Now the square root of 5 is 2 point something. So 2 plus 2 point something. Here, that'd be another 4 plus something. This will be 4 something. This will be fine. But the negative 2 minus the square root of 5 is going to be a negative number. And that would make this a negative. So the only answer I can use is 2 plus the square root of 5, because I had to throw the other answer out. Do make sure you check exact solution, which means if it doesn't come out even, I'm going to leave it. If it doesn't come out to a whole number, I'm going to leave it in strange form. Okay, let's combine this to 1 log. So this will be the log of x times 2x plus 1 equals the log of x plus 8. Well, I've got 1 log base 10 equaling log base 10, so that means these parts must be equal. I'll have 2x squared plus x equals x plus 8, or 2x squared minus 8 equals 0. Factoring out a 2, I'll get x squared minus 4 equals 0. So x squared equals 4, and x equals plus or minus 2. Checking the answers. So be 4 plus 1, 5, 2, and 10. So the plus 2 works the minus 2. So be negative 4 plus 3. The negative 2 will not work. So x equals 2. Always check those. Don't just automatically throw out one. Always check them. Now here's a summary of our strategies for solving logarithmic equations. If the equation involves a single logarithm, then use the definition of the logarithm. Y equals log base a of x, if and only if a to the y equals x. We can use the one-to-one properties when applicable. So if the bases are the same, then the arguments m can equal n. If it has several logarithms, same base, combine them using the product and quotient rules. So if the two logs are all same bases, if the two logs are added together, then multiply the arguments. If the two logs are subtracted, then divide the arguments.